Hello, IT. Have you tried turning it off and on again?
Hey, Cypher, what's up, man? And Brumbo, what's up, dude? Yeah, Brumbo, doing pretty good, man. Had a pretty relaxing Father's Day, thankfully. Oh, I didn't start the timer. Get that going. Hey, that was the music. There. Make sure I got everything set up. I hope everybody had a very good Sunday today. Cracking open the Jocko. As I'm sitting here thinking about it, so I'm warming up the lab right now. I think I figured out what the pickle problem was from last night. Here, I think I got everything warmed up. So we've got a new error over in the exploit, which is good actually, because we wanted a new error. The error from last night was caused by basically crapped out input data. I fixed that now. Just went through and reran the pickle. What's up, everyone? Hope everybody had a fantastic Sunday. And if you're a dad or got to spend time with your dad, happy Father's Day. This one I was expecting actually to be a little bit rougher, because this is my first Father's Day without my dad. He passed away a little over a month ago, and it feels like it was so much longer than that, but I guess that's how it works. Time has been, for the past year, time has been flowing kind of weirdly for me, and that's because I guess grief just does that. Believe it or not, I was talking to Agent Zero about this, my oldest son. He's 6 years old, and I tell him, I was like, "Hey, kiddo, you're having to deal with a lot of death and grief at a way younger age than I ever had to. I've had to deal with it in sporadic events, but this past year it has just been one thing after another. So I've been talking to him about it, trying to give him some perspective on it, not just think that, hey, this is a common everyday event, don't let it phase you. No, they're important events." So I guess time over the past 9 months has been just flowing very oddly for me. So, anyway, let's see what we can do here on Hackbot. So we got a new error. So last night, we're getting an error basically saying that it couldn't find a key in the state table. And it's like, yeah, we know that key is there. Finally, what I realized is, as we're running through this, the way we're executing some of these things, like for example, coming in, running the exploit graph right here, we're doing it inside of something called a thread. So you notice how it says like turn 1? Let's see if I can find an example here. Let's see. I don't know if I have a really good one. Here you go. Notice how this one says turn 2. So what's happening is it's loading up a state table to kind of run through this. And when it does that, the load pickle logic in here it registers that there's already a state table. So what does it do? it basically pickles it all together, and it was crushing the pickle file. So actually, let me do something real quick. Let's see. Let's look at that pickle file that's using to save our data. Yeah, so it was literally just updated. So what I'm going to do is I'm going to make a backup of it. So we'll copy that. So now, if we go through and we start having that trouble again, we could just reload the pickle file. I already went through and had it scan the box, and that's why we've got a new error in here. So let's go take a look at that. Oh, this is weird. So for some reason, it's saying it could not build the language model prompt. So let's go take a look at that. Let's get this party started early, because I'm excited here. Oh, cancel. Don't tell me you crashed on me, you piece of crap. I do really like Royalty S, but man, when it messes up, sometimes it messes up real bad. So it just crashed on me. Let me get it started back up here. Hang on one sec. Let me get logged into it. Yep. Okay, getting all reconnected. One of the favorite things I like about it is it will come back and do all these reconnections. All right, so we're getting a problem on 218, which is here. Did I not save prompts? Is that the problem? It doesn't recognize that that's a valid sweep here. I think that might be the issue. I still don't know why it's flagging on this exploit task here, but there is actually a like a comment decorator we could put over in PyCharm to tell it, hey, don't worry about that. Back here, let's try rerunning that. So what we have to make sure and do is we want to start a new thread every time we do this, because to have it actually load the pickle from disk, we need to make sure we're sending it a blank state table. So let's go ahead and do that. Right. So all I'm trying to do is just hit that first tool node. I want to kind of see what it does. Unfortunately, looks like we hit an error. None type object has no attribute invoked. So it looks like it's getting the same error. Let's see here. Where's our error coming in at? For some reason, it's saying it doesn't like that. Still, let's go see what's going on here. Oh, you know why? Because I'm an idiot. This function runs and doesn't actually return the chat prompt template. So we built up the constituent pieces here. Let me bring this over. So we built up the two pieces of the prompt, right? The system and user template, but didn't actually return the chat prompt template. So it's a function with no return. That's funny. Let's try this one more time. Things that make you feel dumb. That's one of them. All right. So let's let it run here. So we'll take a look at the full trace. Hopefully it's going to get to the exploit step tool node and then end. And we'll follow the trace. We'll see exactly what it's doing with this. Please don't tell me we got the same error. Oh, it says it's missing a variable. I thought we only had 2 variables in there. Let's see, we had target and context. Missing variable task? What? Let's go double check that real quick. No, we should only have... Oh, that's because, yeah, we did target instead of task in here. Yep, that will... So we extracted the target IP instead of the task. Whoops. So let's go look at where we're bringing that out and we can grab this. So we have our exploit task, exploit step. Actually, what I want to do is do a minor change to this because this is actually supposed to be exploiting a step, not a full task. So let's redo a little bit of this. And rather than the target, we don't actually need this, but let's go get what the step is. So our step string is going to be from our... Take this out too, because that was some debug. This is going to be from our current step. So what we'll do is, current step, what we'll do is we will get... we need our state table. Step task, that's what we need. Let's call it that. Ooh, there we go. And then we'll change this to step task as well. There we are. Alright, so let's save this and then we can let it run. It looked like it was getting so close too. Cannot wait to see this step loop run. Because this, like I said, this is going to be probably the single hardest agent to build is going to be the exploit agent. We get to post exploitation, it's not going to be that bad. Spin it up again. So we get through. If it can get through the, well, I just wanted to kind of walk it through the tool node. Once it gets to there, we're going to go through the entire trace and break it down and see what happens. Still getting errors. What the heck, man? What is this? Type int objects not subscriptable? Why is that coming back as an integer? That should not be an integer. Or no, for some reason it thinks current step is an integer. Maybe I grabbed the wrong variable. Let's see. Oh, current step is an integer. Yeah. It's exploit step. Dang it. Current step is what step we're on as far as the task goes. So the exploit step indexes off of that. So yeah, I grabbed the wrong. Let's see here. Yep, so we'll come drop this in. So our exploit step, and then from here, we want to get the step task. Make sure I've got this right. So our exploit step, our exploit task, right here. So we have an integer, we have a list of our steps that we're going to execute, and they're basically, it's an indexed array, so it should execute them in order. Our steps are, we take our steps, so this is an array of those exploit steps, these guys here. We get that current integer, so we, from our exploit task, we start tracking what the current step is, so we've got that. So then our exploit step, right here. So yes, we want that. That gives us the current working step that we're on, and then what we want is the task. So step task. There we go. I was referencing just the wrong key in the state table. All right. 5th time's a charm? Let's see. Yeah. Come on, step processor. No, you failed me. List indices must be integers or slices, not built-in functions. What? Was I just completely off my A game last night? Let's go look. So line 227, when we set this to working, that's weird. We're referencing the correct thing. Let's see. So we go to the state table, get the task. Let me kind of diagram this out a bit. Let's see. So from the state table, go to our task. Now, for some reason, unexpected type. So where are we setting the current task up here? Is it being set like all the way up here? No. Current task should have been extracted up here. I guess it's not. Hey, Bobby, what's up, man? Happy Father's Day, dude. Oh, maybe it's just because I didn't extract current task out of here. I thought I did. So we didn't extract the helper is what's happening here. So let's go. So we got the... Oh, I know why. Because we did a refactor on this, and we took out that variable. And rather than actually extracting it as a helper, we're actually referencing the state table directly. That's what it was. So it's trying to reference an unknown variable, and I think we just had a bit of data sticking out in here. Now for exploit step, though, we did extract that one. So... yeah, so our exploit step here was actually our integer. Wait, no, that's not correct. That should not be exploit step. That should have been the current step. Yeah, that's what we changed some code back up here, and now we're hitting this, and that's where we're getting the errors. All right, there we go. Now things are starting to look a little... That's pretty good, though, because once we get to this, we set it to working. It's going to return the update to the state table. Then we should be able to go, hopefully, hit the tool node, and we can start digging through the trace on here. Nice, nice. Happy Not the Mama's Day. Dude, that's an old reference. Not the mama. Dude, when I was a kid, I loved dinosaurs. The show. And the creature, right? But then I tried to go back and rewatch it as an adult. I'm like, dear God, this is cringy. I couldn't make it through the first season. And I know usually you have to just trudge through the first season of a show to get to where like the show really hits a stride. It never hits a stride in the first season, typically. I couldn't do it with dinosaurs, man. I tried to go back and rewatch it. I was like, this is terrible. This is hella bad. Hey, all right, cool. Let's go check the trace out. Looks like everything is working fantastic. First thing I want to check, though, is I want to check the output of this and make sure that like our AI messages are not getting duplicated in here. So let's go and take a look here. So we should only see like... I don't see the full state table, which is kind of weird, but all right. One thing I remembered last night is we have these basically fake AI messages coming through, and we have it reference certain portions of the code like, hey, this is what we're doing at this part. Think of it almost like debugging. At the same time, though, it's meant to exploit. I'm sorry, it is meant to explain as it's running through the exploit code what it's doing. Salty, my brother. Happy Father's Day, man. Maybe if I rewatched it, though, you might have a point. Maybe I just remember it differently. Dude, there are so many things I remember from my youth that were awesome, and like I tried to do them as an adult, and like this freaking sucks. Namely, cereal. I can't do cereal anymore. Like I think about Fruit Loops or Lucky Charms or anything, and I'm like, this freaking sucks now. This was amazing when I was a kid. All right, so what URL did we hit? We did hit panel. Actually, let's back this up a bit. Let's do a default render on this. Okay. Let's go kind of look at what our messages keys look like. Okay, here we have the full message keys. Awesome. I'm actually going to compress this a bit. So we have a lot of messages happening here. All right. So Stinger passes everything over to the exploit agent. Exploit agent says starting task 5, which is get a remote code execution from a web shell. Exploit agent then says has no validator, so or sending it to the validator for the pre-flight check. No initial access payload was available, so we're passing it back to the exploitation agent. Agent says, okay, I'm going to rework this task then. And we say, we have a couple of different AI messages that happen here. So we still want to go take a bunch of those. We do need to go add some of this to explain what's happening in various steps, because we're seeing stuff from the agent, right? But then it goes to the step planner. So we want to throw an AI message in here so the step planner can explain what it's doing. And then the exploit step processor, we want to do the same thing in there. But so far, it looks like it's working pretty decent. Let's see, I'll analyze the target information to suggest viable exploits for gaining remote code execution through a web shell. Based on the data provided, there's a file upload functionality on this web server that could potentially be leveraged. So it comes through and says we could upload PHP web shell with a file extension bypass or with a content type bypass, or maybe try a FAR file, a PHAR. I've never actually seen those before. So cool, I like where it's going with this. And then last thing it says, I'll help you navigate to the upload form of the specific URL. Let me first check if the URL is accessible and examine what's on the page. And so it does a GET request, which is perfect. We already have this. It would have been fine to go do it. But when I'm doing an exploit, even if I have notes that say, yeah, this is viable, I still go back through and validate before I start firing stuff off. So while this could be avoided, it's not a bad thing to have in there. Imagine turning your back on Toucan Sam. I feel like they turned their back on me first and just started making crappier cereal. That's my story, and I'm sticking to it, man. If you want a cringy show, there's always Small Wonder and Alf. Dude, Alf was a dark show because a lot of people don't realize how that show ended. The show literally, the entire premise of the show is that the government is hunting Alf and trying to find him. And they left off the show because the show got canceled on a cliffhanger. And the cliffhanger is Alf gets captured by the government. So that cliffhanger became the end of the entire show. And then Alf is just, oh, okay, the show's over because Alf is now a government lab rat. Which one was Small Wonder, actually? Hold on. Was that the girl robot? Oh, yeah. That was a creepy show, too. I remember that show. Yeah, the girl, cybernetic, and, like, her name is Evie, I think, and they have, like... Was her name Evie? No, I'm getting my 80s TV genres mixed up. That was Out of This World I was thinking about. That was Evie. Let's see. Vicky, yeah, and it had like an acronym to it. Small Wonder, what did the girl's name be? Hold on, because I used to know this. It's VICI, Voice Input Child Identikit, which identikit's not actually a word. I think they just made that up. But anyway. And the only reason I know that about Small Wonder, I knew about Alf, but I saw some YouTube short about small window. That's what brought it up. All right. So cool. We got all the way to the tool call. Sweet. So we're down here. So if we take a look at the plan, we've gotten to the tool node. We want to do a quick double check of the analyzer. The analyzer is going to be kind of like the validator. We're going to basically duplicate the validator's functionality with a twist that, hey, if this failed, you need to suggest a correction and then send that up to the step processor. So we'll have to have, I need to double check something in the exploit steps and make sure we have something for analyzing and correcting stuff that we're working on. I think it shows your age at this point. Yeah, no kidding, man. What's weird is they always had her like, and nobody even questioned, like she was in that like outfit from like the 60s or 50s, really, like the really old style dresses, and nobody even questioned it. Even like they think they had the girl going to school. And I think, and then later in the show, she gets an upgrade where she can actually wear regular clothes. Dude, I totally show my age. I don't try to hide it. I was like, how old are you? I'm old enough to have lived through multiple presidents. Many, many multiple presidents. Let's see. Oh, speaking of like old and remembering how things were. So Oni, a friend of mine is in North LA right now, up in the Hollywood Hills. And she said she broke out in hives because apparently the little bit of the crowd dispersal stuff they're throwing out there was wafting up that way. Yeah. Let's see. Yeah, I think I would have kind of... We're going to basically mimic the validator here. If we do this. So we'll have to go... We will go make a new prompt eventually. But we don't need... Yeah, I know you're happy to be out of LA. Who would have thought Escape from LA was going to be prophetic? Let's call this exploit step analyzer. So this is going to take in a stinger state. And eventually we'll have it return something here. It's going to leave that for now as a placeholder so I know where the end of my function is. They blocked the 101 freeway in LA, so if I was there, I'd be so pissed. Yeah. I would have thought Escape from New York would have happened before Escape from LA, but, you know, it shows what I know. All right, so for the exploit step analyzer, what we're going to do is we're going to take this data here. Actually, I take it back. We're going to need to do something real quick because it's not just the analyzer here. We're actually missing a node, what we're going to need to add. So we're going to need to add a step update node. Step update. So that we can take the data from the tool node and update the step on it. So what we'll do is just do a quick update. So we'll hit this and then we'll come up here. So that way we can, basically like when we did the host update and we went through it, what we're going to do is we're going to come through on a step update and then update the output from the tool node. Because the tool node literally just takes in the tool call and spits out the output. That's it. It doesn't allow us to embed any logic in here. So instead, what we'll do is we'll hit that. We'll do a step update. That'll store all of our output that we're using. And it'll be good. So before we actually get to the analyzer, we need to actually change this. So this is going to be exploit step update. And it'll be very similar to host update. I'm an LA refugee. It's so sad too, because California is such a pretty state too. It just gets overrun by the large population centers, pretty much. And so like they don't understand how the rest of the state's living, and then they pass weird laws that they think are going to help with everything. In actuality, it just causes way more issues and more problems. And then they also don't just pass it for, like, let's say LA or LA County, they pass it for the whole state. So stuff that makes maybe some sense for stuff happening in LA and San Francisco makes no sense for people living out in the country, which there is a lot of in California. So, I mean, that really happens on every state, though. That's not a uniquely California problem. It's just, I think California has dialed that problem up to 11. All right, so what we want to do here is we want to get we're going to follow this very similar logic here from our exploit planner. So let's get some of this stuff here. Actually, I need to look at something real quick. Yep, so from task, current task, output, exploit step. Yep, we do that. All right, cool. Actually, I think these are the ones I actually want. Basically, I'm going to duplicate this piece of code right here. Just like this. Because all this code right here is doing is finding what's the current working step and checking a few things. Actually, do I even need this real quick? Yeah, we do. We have to go find the index of what's the current working step from the exploit task. Oh no, sorry. Well, first thing we're doing is we're finding. Hold on. I started this diagram. I got sidetracked. Let's go make this real quick. So what's happening here? The way things are embedded here is we have our state table, and then that's basically a dictionary. Under this, we have our tasks, which is going to be an array. Under tasks, we have an output key in here. Well, let me back this up again, because from here we want to get an individual task, and that's basically a dictionary. Little curly brackets. Under here, we have an output key, which the output is another array. And then as we're digging through here, in this case, output is going to be our exploit tasks. That's what this is right here in this particular situation. And then, so from there, we have our exploit task. That sucker is basically going to be a dictionary. And this is where I'm getting confused, because look at all these layers. We're going these layers deep. That's where it's getting me up. All right, so under exploit task, we have an array of steps. So under here, we have our steps. That's an array. And then each of those steps, under that, we have an exploit step object. So the state table's getting kind of dense here, but it's all part of the logical tracking of everything. So from here, from steps, we have an exploit step. And think about, like, if you've learned basics of cybersecurity, this is stuff you're doing more or less automatically. After a few reps, you learn how to do this. But we're having to extract all of this stuff that comes very simply to us in our mental models into computer language. And this is where it's getting to be a pain. And so from our exploit steps, we have, actually in exploit task, we have a helper here, which is the current step. So let me go update this real quick. Let's take this down, and do one more. So we have our current step indicated for that exploit task. And then in the steps, that's where this reference is down here, whatever our exploit step is. So here in the exploit step, that's where we have the status. So that is ultimately actually what we want to update here, is the status of that step. So we have statuses for the individual steps, the overall exploit task, and then the task itself. Tried to just validate that everything was working correctly. LA broke the dial there beyond 11. Dialed up to 17. I believe it, man. Okay. Now that I have my little handy dandy diagram here to keep track of what I'm actually extracting out of here, there's actually one more in this. From the state table, we actually have the we have a tracker for the current task too. Current task, there we go. So I kind of want to do the same way, but I think I'm going to do this. I think I'm going to do this hard mode. So let's get wait, what is this from? Oh, it's from async. Oh, that's what's been causing. Oh, that's what's been causing some of the name collisions, because we have fields called current task, but also from async io.task, there's a current task in there as well. Got it. No wonder why we've been having some name collisions in here. Okay. Anyway, let's go extract this out real quick. So this is going to come from the state table. We'll get the current task, and then we'll say our task is going to be from the state table, and that's going to be indexed on current task. And once we have the current task, we're going to go through the output and we're going to figure out which one of those is working. So that's where this little for loop can be handy. So we'll come in here. So this is going to find us that, and we'll just initialize this exploit task index. That's going to be at -1 right now. So we can do some error checking with it. And in fact, what I'm going to do is we're going to call this, let's see, current task. This should be an integer. I'm going to start doing this, and it's going to be inconsistent because I did not do this for the first two agents, but I'm going to start putting these type hints into Python to try and help keep track of it. Let's see. So for task, what do we look at here? Task is going to be just a task type. We don't have that imported, so we'll import that from states. There we go. There we go. We're typing all this together. All right, cool. So once we have the exploit task index, which is what we're going to get from here, eventually I will need to come through and add a bailout earlier than this to find out which one is, in case we've run out of suggestions, in which case it would bail out of the agent. And that would be where the human interrupt comes in, but it's not a big deal. That's a problem for future Blaise. That's what that is. All right, so once we have the exploit task index, what we're going to do is we will get, from our exploit task, let's go ahead and break out the current step here. The current step, this will be an integer as well. We're going to say that is going to come from, we'll do task, and then we'll do exploit task index here. So that gives us the element of the array. And then from inside that, we have a current step. Type dictionary must be a string. Oh, you're right. Actually, I forgot. We're missing something in here. So our task is going to be that current task, and then what we want is from the output. There we go. Now we're talking. Now what are you complaining about? This is fine. Let's see. So we're going to get, I think, just current step out of that. So we'll extract that out. Let's see. So we find the element of the output array from the task. That's going to give us our current step. Actually, what we want is, I take that back. We don't want this. What we want, instead of the current step, is actually we want the exploit task here. And this is going to be a type exploit task. There we go. Now we're talking. And then we want to go through the steps. I'm glad I made this little diagram of the state table. So for the output task, so from our exploit task, we can get our current step. So we'll do current step. And then we will set that to from exploit task, current step. Here. And what we'll do is we'll say step would be exploit step type. That's going to come from our from our exploit task, and then that's going to be steps. Doing all these references. And we're going to index that on the current step. There we go. I don't get why it does this. So in the IntelliSense in PyCharm, it's like, hey, we expected to get an exploit step type back, and instead we got an exploit step type. Why? It did the same thing up here, too. In this case, expected list of exploit steps. Okay, whatever. And I don't care. You're in the right spot there. Okay, let's go ahead and just call this our exploit step. Make it explicit what it is. So that's our exploit step. And then what we're going to do in the step is we want to extract some data from the tool call. So we'll go to the last message, we'll get the tool call, we'll see what the tool is and the output, and then we'll go update that. Now the easiest way to do that is actually go look at the recon agent, because this is very similar logic to what we did for the host update function in here. Well, actually, did we do this in output formatter? No, probably not. How did I do the host update? Let's see. Yeah, that comes from the host update function. I wanted to ignore these. Oh, so we literally, actually, we did this over in, that was a utility we had. We had host update in here. Forgot about that. Yeah, in this case, we shouldn't need that, though, because this was... We actually did this as part of a language model call. We shouldn't need that, though. Let's come back over. Yeah, here we are. This is actually what we want right here. Now we're talking. So here's our output formatter. Comes through. The output formatter, for anybody who doesn't know, this was so if we had specialty output that, let's say it got really big and chunky, for example, Nmap, because we're using Nmap's XML output, and that gets just crazy chunky because you have all the XML scaffolding that kind of goes around it. So what we did is we made a special output parser for Nmap, and then for when we format that output, it goes through and it pulls that data out, and it basically uses the language model to reformat it into a friendlier output. So we don't necessarily need that. That is what I wanted to do, though. Let's see. I want to try something. Somewhere in here, we actually updated the tool, though. Let's see, what was this in task? It was, yeah, the tool list. So it should be referenced like this. Ah, here it is. This is what I wanted, right here. So we're gonna go get that sucker and update it in here. So let's come back over to our exploit agent. Actually, where did we do that at? Let's see. This was in the recon agent. Okay. But we're not doing that in the agent. The tool calls, in this case, they're originating from the step processor. So that's where we need to update it from. Yep. So here's what we want to do. Let's do this. That's right. Here we go. This is actually the part we want, is this right here, is whatever the tool name is from the response. But we actually can take this chunk of code here and kind of get the same net effect. Let's do that. But what we're going to do is, instead of updating the status, what we're going to do is over here on the exploit step, we're going to update the tool. So now we'll have captured the tool call here. Should be fine. See, exploit steps, steps, get the current, basically the current step. This is not a string though. See, from output, exploit task index, and then so we index on that list, we bust out the steps, we index that on the current step. Doing this correctly? Yeah, no, this should be exactly the same, because this should update the status to working right here, and this should be this status. Should be fine. This tool. Tool's a list of strings. Yeah. I wonder why it's registering this as a string instead of a list of strings. I'm going to leave it for now because I know the typing is getting confusing for PyCharm. I'm not going to worry about it. So then once we get to our current step, what we want to do is we want to take the response from that tool call. So let's get our last message in here. So we'll get from our messages. Let's get the last message in here. How did I do that in Recon City? So there's our last message. We do a quick check to say if it was a tool call. And then where did our tool output come from? Oh, it's the last message content. I think that's what we want to add into this. Hey Bees, what's going on, man? What are you doing? So we're working on an AI hacking agent to play stuff like Try Hack Me and Hack the Box right now. So it currently is looking pretty good. We're on, it's a very early project. I've been only working on it for a couple months and I only work on it for about 6 hours a week. But the idea is we've got an overarching, let's say AI agent that's going to be a supervisor, and then we have these primary agents. We have recon, enumeration, exploitation, and eventually there will be a post-exploitation one for handling C2 interactions. We just haven't gotten there yet. Currently working on the exploit agent. So we've done recon and enumeration of a very simple box. We're doing root me over on Try Hack Me. And so what we're going to do, let me add an hour to this. What's going to happen now is we're actually going to try and get a web shell onto the target and get code execution that way. Once we can get to that point kind of reliably, then we'll start working on the post-exploitation agent. So we've got some logic we're building in here, different language model calls that are happening, and basically just having a good time. A lot of fun. Right now it doesn't think a lot. It's mostly just following the workflows. Eventually, we'll back out how much data we're giving it, and then we will let the agent kind of decide what its next task is. But right now we give it like bullet points, like, hey, this is what you should be doing as you go down. All right, so let's see here. So then in our exploit step, what to do? Let's see. Thanks, man. It's a fun project. I've been enjoying the heck out of it. I just wish my office wasn't so hot. I moved all my computers into one room, and now I'm just baking in here. Let's see. So we capture the tool output. And then what we want to do is come over to our exploit task and update that. So if the last call was a tool call, this is when we want to do this. Otherwise, we're just going to skip over a bunch of this logic and return what is essentially data that's going to clobber itself, which is fine. So what we want to do is we can essentially use this exact same data right here. We should be able to. Let's see. Yeah, current exploit index, steps, current step, and then from here, what we want to do is get the output. And what we'll do is we're going to append onto that the tool output. My goodness, these lines are getting ugly. It's not a string, though. The output is not a string. It is a... Oh, actually, I take that back. Output is expecting a dictionary. So what we'll do is we'll just scaffold this. We'll just say output is then going to be like that. There we go. Because it's expecting a dictionary to come back, but that's okay. I think we're good there. Then what we want to do is, since we've updated this on the state table, so a quick refresher, if we're just reading data, yeah, we'll come through and we'll extract stuff like this, and we'll take it like back out of, we'll take it back out just to do a read. But if we're going to kind of send data back, there's different ways to do this. The way I have chosen to do this is we update our local copy of the state table, and then we return the keys that we want. So in this case, we're updating tasks, right? So we could just go return different pieces we want. Instead, what I'm going to do is I'm literally just going to return the entire task key, and it's going to sync in all the changes that we've made. So from our task here, what we're going to return is state tasks. So we update our local book of it here, and then we emit that to the master copy that the agents are keeping track of. I think that should be good right there. Yeah, I think that'll be good right there. Yep, okay, cool. I'm trying to think if there's anything else I need to do with this real quick before we do this. One thing that actually would make this a little bit more efficient is if we actually brought this over and put it under this if scope here. And then we just come in here. Otherwise, we just else. And then we just return a blank dictionary and tell it, hey, we're not updating anything. Actually, I should do, I've been skipping over this. So let's do a little bit of housekeeping. So let's call this AI messages. And this is just going to be, I believe, a blank array. Hey, John, what's up, dude? Mr. Mac. Hope you guys are having a happy Sunday. Because what I want to do here is do a little bit of checking. So what we'll do is... So what we'll do for AI messages is we'll append a new AI message here. It's AI message. And this would be from... So what usually what I do is I'd say what the... where this is coming from. So in this case, we'll say exploit step updater. We'll say appending tooling output. Okay. I will say tool call output. That way. And then once that gets done, what we would also do is we would just return that to the messages key here. So we'll say messages. Messages works a little bit differently in that is when we return something, it will actually get merged in there. It'll get like merged and unique versus the other keys. Once you kind of return this from the function, it just gets BTFO'd. Whatever you return overrides it. Messages is a special case in here. And in this case, if that's, we actually need to do one more thing here. Let's do, I don't even need this. We'll just do an AI message in here. So AI message, and what we'll say, same thing here. The exploit step update. No tool call output thread. Go. We'll just say that. Awesome sauce. And then now we need to go wire this up. So this exploit step update, we need to wire this thing into the graph. So let's do that. So it'll be here. Let's add an edge to this. So actually, I want to break this up just a wee bit. Because usually what I'll do is I will do node and then edge. I'm sorry, I take that back. We'll do an edge and then a node. Where did we add the step? Oh, we couldn't add the step earlier because the step to get to the basically the execution path to get to the exploit step planner happens during this conditional jump up here. So there's no precluding edge to this. That's fine. Let's go add that in here. So we'll do exploit workflow. Let's add edge. That's right, we're edging right now. Let's see, the edge is going to go from the exploit step tool node, and we're at end. I can't type. Can't type today. Disoriented. Let's see, we're going to go to our exploit step update. That's what we're going to call it. And then we're going to define a node on it. So we'll do exploit workflow, add a node. My keyboard out of center. There we go. And so the node we want to add is this new one we just referenced. So exploit step update. And then we just tell it what the function name is that we're referencing, which in this case would be, what do you, my scroll wheel just went bananas on me. Hack the planet. The leader was Ezekiel, the Finnish guy, right? I don't know. I'm not even sure what you're referencing there. System 32. Well, welcome in, man. As far as I know, the leader was Zero Cool. Oh no, I take it back. Technically, the leader of Hack the Planet was Razor and Blade. All right, let's see if this reflected in our graph now. I think we've got an error in here because we see the tool node, but we don't see this. Found edge starting at unknown node. Oh, it's because I have a typo in here. Right here, exploit. So we got an error from the server saying, hey, I can't compile the graph, basically, because you have a mismatch of the names. All right, cool. So eventually this is going to form its own loop right here, and it's going to execute through the steps. When this is all done, we'll actually link this over to the exploit validator to say, validate the initial access exploit was actually constructed correctly and it works. Or to examine the output to say, hey, can we render that this was completed correctly? Nice. Nice. The agent is growing. Let's go do a quick run on this. Let's see what happens. Julius Kibamanki was a member of Hack the Planet, not the leader. Wait, was there actually a group called Hack the Planet? Because if so, I'm surprised I've never heard of them. We got a key error. All right, let's come back. Let's go check the trace and see what happened. $239. Oh, really? Wait, we got a key error from that? We should have had a task 5 in there. Let's go just take a look at that line, 239. What's going on here? Oh, it's because I'm an idiot. We got the current task integer, but we didn't actually tell it the correct array to pull this out of. There's a task key, and that's where the array is housed. There we go. There was a movie based on it too? Dude, what movie? Because I have an entire section in my media server of like computer hacking movies. And I need to go get this, because now I feel the collection is incomplete. Granted, I know the collection's incomplete, because I don't curate it very well. But the section is still there. Let's see. So after I went through all that trouble of diagramming out the state table, I still got the key screwed up. Let's go try this again. Hey, all right. We got some places with no errors. Let's go see, did we get the actual expected output? So we want to go to step 0 got set to working. Output. Ooh, this did not get... We got the tool output, but for some reason... We got the tool, but not the output. For some reason, it did not capture the output. Rip. Rip. Okay, we can remember that. Hackers from 1995? Wait, was that actually based on real people? I thought it was just Hollywood trash this whole time. Don't know, girl. When I say Hollywood trash, I love that movie. It's like a pug. You know, the dog? It's so horrendous. It's beautiful. That's how it is. I've never met a cute pug. They're all ugly as sin, and they're so ugly, they have wrapped around the continuum of ugliness to become beautiful. I like where it's going. It's fortunately, it just looks like for some reason we did not get the output captured. Oh, yeah, we did. No, we did not. Output is blank. Rip. So we got the tool appended to the tool input, but for some reason the output didn't. So let's go double check that. Actually, where's our messages? Because our messages will give us an indication of this. We got, oh wait, the last message we got was the tool call? Yeah, it actually said, oh, because I'm a dummy. I was looking at the input. That was to be expected. We should see it over here. We look at output, let's see. Let's find task 5. So task 5, if we look at output, we want the first one, the first step, there's our output. I'm an idiot. I was looking at the input state, not the output state. That's all right. It's working, though. Oh, so other way around. The group was based off of the movie. Like, they drew inspiration from that. I want to riff on them for that. However, the extreme crush I had on 1995 Angelina Jolie was literally one of the reasons why I started like getting interested in hacker culture and stuff. And it was very shortly after that I went and bought my first 2600 magazine. So I cannot cast aspersions whatsoever. All right, cool. But this is doing stuff. This is fantabulous. This is amazing. So the task was to navigate to the target URL. Wait, is that the correct IP address? 255.215? Oh, sure is. Okay. When you throw a 255 into an IP address, it throws me for a loop. Even though it is technically valid, it just threw me off. All right, cool. Now we can just do the step validator. And once the step validator's done, which is really what this analyzer is. This is going to be the step kind of like validator in here. And then we throw this back up here. So analyzer will actually we'll have to do two things for this. Analyzer is going to have a conditional jump back to the step processor or to the planner. So analyzer will say, hey, by the way, did we complete the exploit? If we did, then either go back to planner or there actually will be like a return. There's one more in here. Over to the exploit agent. basically sending it back to the exploit agent node. So this will also be a conditional jump. Yep, I think that's what we'll do. IP class C, ew. As long as it's not 256. I know, right? Entropic. What's up, dude? No, anytime I see 255 at an IP address, I get a little bit skittish. And in fact, there's really dirty networking tricks you can do. And I just recently wrapped up a penetration test for a client that they have a very, very funky environment. So funky, in fact, I told Tyler Ramsby, as I was talking with him, I was like, hey man, I'm going to go make, because he likes doing CTFs on stream. I can't really stand CTFs. I told him, hey man, I'm going to go turn this into a CTF and make you play it. That's Infinite. Thanks for going online. Welcome in. Man, it's going pretty good. Had a good Father's Day today. I didn't have to really cook anything. Thankfully, I smoked a brisket for the first time in like a year because my smoker was busted. So I spent the entire last weekend fixing it and repairing it. And so it was nice because I got to finally eat some of the brisket today. And that was pretty much all I did. I literally, like, I went to church. I went and saw my mom to go check on her and pick up mail and other stuff. I came home and took a nap. And then I ate brisket and came on stream. That's it. It was a pretty chill day. What's wrong with CTFs? There's nothing inherently wrong with CTFs, Cass, but at the same time, I work in offensive security. I do penetration testing and red teaming for a living. So it's a bit like just getting done with work and then go doing more work. It's the same reason I don't personally like bug bounties, because it felt like I was working all day for my salary and then potentially working at night for tips. And so it just got to be a bit of a beatdown. So one of the reasons why I like programming so much, and I'm trying to become better at it, is because it is still a very technical field, and I can do offensive stuff with it, like what we're doing with Hackbot right here. But it is just far enough removed from my day-to-day work that it doesn't burn me out. So it is very similar, very parallel, and a lot of times intersecting, but they're not identical, right? So it doesn't burn me out coming in trying to do this. And CTFs kind of do that. And also, I've seen so many real networks. I've been in offensive security for 7 years, and I've been in IT for 15 years. I have seen so many real networks that a lot of times the CTF is so nonsensical that it bugs me. It's like, okay, yeah, it's pretty much like Sudoku or crossword puzzles for hackers. That's what they are. That's what CTFs are. So they are really great for learning though. So come to think of it, this is probably the only way I'm going to enjoy CTFs, is having Hackbot go through and play it for me. Eventually, once we get all 4 of the primary agents stood up, because we only have 3 of them right now. So come over to Stinger. These are our primary agents: Recon, Enumeration, and Exploit. So we're working on Exploit right now. Once Exploit is finished, we'll have one more, and the 4th and final primary agent, which is going to be for post-exploitation. So we'll have an agent that is designed to go and talk and handle tasks through a Mythic C2. And that'll be really interesting because there's a lot of Mythic internals that I've got to go learn. But then eventually also, there will be specialty agents assigned to here that these little guys can call. So for example, if we come across something, for example, with Azure, and we want to do Azure reconnaissance, boom, we've got an Azure specialty agent. Or if we want to do enumeration, stuff we find in Azure, same thing. So this Azure specialty agent will be available almost like a tool call from these guys here, where it can sit there and it can work with them. I blue teamed once. It was a very long day. I did blue team and like system administration for 7 years. And then I've done, like I said, offensive security for 7 years, basically 7.5 and then 7.5. So literally half of my time has been split amongst the two. And I enjoy the red team operations a lot more. Although to be quite frank with you, I could have been making more money sticking to blue team and working down that path. So there is definitely a give and trade in the two of them. Blue team, you're going to make more money, and in a lot of outfits, you're going to be a lot more stressed out. In offensive security, it's a lot more competitive. The pay is not as good as blue team, and a lot of times the stress can be about equal or less. You get a little bit more psychic income having fun going through hacking all the things than trying to protect all the things and praying to God they don't find the one crack in the in the wall to slip through. What happens if you don't find any flaws when you're pen testing? That is exceedingly rare. So I've probably done a pen test. It's slowed down quite a bit now, but for the most part, I've been at my current job for 9 months, and so the pace is much slower. You have more time to work on these assessments. But at my previous job, I basically did a pen test every 2 weeks. That was the average. Some of them were smaller, some of them were longer, but that was about the average every 2 weeks. And I worked there for 6 years. So you're talking, I keep having to do this math, but for 6 years, essentially, I did 26 penetration tests. So for round numbers, let's make it 25, right? So I've done roughly 150 pen tests over that time. I can count on one hand the number of times I've had 0 findings on a report. So it's very rare. There's usually always something that can be improved or worked on. And in fact, the penetration test I was just on right now, I was kind of pissed because I did not complete the primary objective, and there were several issues with it that came about. It's all right. You find those issues, you go through and you correct them, and then you move on. There's no point in dwelling on them. So I didn't have very many findings on this current penetration test I just wrapped up. And I hate that too, because when I don't have as many findings, it's harder to write the report. If I have a bunch of findings, there's more to write, but ironically, the overall effort is, in my mind, easier because the findings basically dictate how the report evolves. Whereas when you don't have many findings, it's kind of hard because you have to actually go through and claw and explain all those times you failed. Can you hack my mom's Facebook account? Hold on. Let me see. Let me check something real quick. One sec. Hold on. I'm looking. See something real quick. No. Is OSINT a big part of your pen testing job? It depends on what we're executing system. If it's a red team where we're coming in and actually trying to evade detection, then yeah, it'll be a big part of it. If it's something where we're doing what's called seeded access, where we're doing more or less like a simulated compromise. So somebody did get an actual, let's say like we're simulating somebody getting a phishing payload or some kind of malware on their system, and we start from that point of view, OSINT is not as important. However, it still does play a part because a lot of times I won't have insight into some of the inner workings or positions that people have in their company. And so as I'm digging through and I'm collecting data, I'll go start doing a little bit of OSINT on the employees. Like, okay, cool. So our objective is to get into this system. Who manages that system? Okay, let's look at the job titles of the employees. All right, this guy has one that might apply. This guy has one that might apply. And so we basically start building out a target list and saying, then as we gather more data, can we refine that list down to, okay, these 2 people or these 3 or just this one guy. This is our primary target on who we're going to go target for this. So yeah, the amount it plays varies wildly depending on what you're doing. Great exploit dev, 1 out of 10, definitely. Well, it depends. Are you doing web exploit or are you doing binary exploitation? Binary exploitation. Here, I have a video to explain that real fast.
You say it's too late to make it. What is it too late to try?
So yeah, that's how I rate binary exploitation. Which actually, I like binary exploitation. I wish I had stuck with it more. I unfortunately just did not keep up with it whenever I was learning it. So it's kind of it's interesting to me. I think really the next area I'll probably move into is compromising more cloud environments. I have a fairly good understanding of Azure, Entra, AWS, but there's a lot deeper I want to go into that. And going back, bringing this full circle, the specialty agents I'm going to build in here, I've got a course I'm actually going to go through to try and shore up some fundamental knowledge I know I'm missing. As I do that, I'm going to build specialty agents for that. So specialty agents for Azure, for AWS, and then eventually also for maybe for post exploitation or exploit, there's going to be a like a custom malware building agent in here because I've got the malware developer course that I have been very slowly going through. But the reason I like this is because going through the course for the sake of the course gets to be painful. It always helps to have like a project set up where you know you're going to take this information and apply it immediately. And it helps you retain it a lot better as well. So that's kind of been the goal of this. I was hoping Hackbot would have these 4 primary agents done end of the month, but I've had a lot of hang-ups in life and they kind of sidetracked that. So I'm going to start working on those anyway. I was hoping it would be done, but I'm going to think about how I'm going to do that. Here. But yeah, that is binary exploitation in a nutshell. All right. I think if I go back over to the exploit agent. All right, so these guys here, we've got the step updater. Okay, next thing we're going to need is the validator or the step analyzer here. So we updated the step to just basically capture data from the tool node. We'll come over to analyzer. It's going to validate, did this step complete properly? If it did, it's going to go to the step processor. One thing we'll probably need, though, is we'll need something to do like an error correction on here. snooze user. Yeah, this is actually Lucy is the one that I'm using right now. I'm getting ready to swap it for a different one because Lucy's a little on the expensive side. Let's see. Yeah, let's go work on this analyzer one. So the analyzer's job is going to be to find out, hey, did we actually get what we wanted here? So let's go do that. Let's see, this will be before validator up here. Actually, I think I want to take validator, and I'm going to just, for simplicity in the workflow, I'm going to move this up. I'm going to move it above all the exploit step nodes up here. He says, thanks for coming online, bud. I appreciate you. And if I know I've said it a lot, but I hope it's very true. I hope everybody's having a really just awesome Sunday. All right, let's see here. I have so much uncommitted code. This is going to be a pain. It's basically going to commit the exploitation agent like in its entirety. I've been forgetting to do that, and it's probably going to be to my severe, to my own personal trauma. By the way, this code is up on GitHub. If you go to the Blaise Bits GitHub and then look at Hack the Bot, that is where all this code lives. And in fact, I'm probably going to go ahead and no, I'm not going to commit it right now. I want to, but I'm not going to. Hey, Tropic, thanks for hanging out, though, dude. Appreciate you, man. My ears. Dude, I love the dial-up sound. I need to get a shorter one, though. I do realize it's kind of long. But dial-up, that was the sound of my childhood. All right, let's see. There's our exploit step processor, step update. All right, let's do this. So now we're going to start the new one, which would be the, we'll call this, I can't type, exploit step analyzer. Actually, yes, I'm going to call this the analyzer because we're going to handle multiple things with this. Because what we're doing is we're basically using something like this reflexion style here. So the analyzer is also going to be the revisor in here. We could call it revisor if we needed to. Think about this. Actually, yeah, I'm going to call this the revisor instead. Revisor? I spelled it right the first time. Revisor. And then, just for grins and giggles, let's go ahead and just set up a return value so I remember where I'm at in this. I saw something colon something. Is that valid Python? Yeah. Hey, Noon, what's up, dude? So, this was something that was, I think, a more recent addition to Python, because Python is not a strongly typed language. This actually does not do anything to the code itself, but what it does do is it provides typing information to your development environment. So I'm saying that, by the way, current step is an integer. So later, if I come down, for example, if I come right here and I say current step equals an array of hello. The planet. Like this. Notice how we get this golden highlight here? Expected a type integer got a list of strings instead. So what it's going to do is it's going to give you a type error. Now it's not 100% because see, like this one right here where you say our exploit step is supposed to be here. Here it says we expected a type of exploit step. We got a type of exploit step. I don't know why PyCharm is flipping out about that, but I'm just gonna leave it. I'm not worried about it. Ad break. God. I need a pop-up for the ads. Something to pop up on the screen. Hang on, we'll let the ad chill out real quick so I can answer System's question real fast. Because I don't know if he's back from the ads yet. I'm back. Okay, cool. I changed it a little bit here because I'm going to delete this line anyway. So exploit step, what we're doing is this colon and then this data here is what your data type is to be expected. Doesn't change your Python. It's just basically for the IDE to be able to go through and make sure you're assigning the correct things to it. So now I get this outline here that says, hey, by the way, we expected a type of exploit step, which is over here on the right side. That's what this guy is here, this class. And instead, we got, oh, it's right here. Here we go. We got a list of strings instead. So it's just basically to throw up errors for the person writing the code. I'm surprised I didn't need that exploit step though. That's fine, we'll take this out. Frozen, I'm sorry, dude. I accidentally muted the alerts in there. But I know I'm a nerd. Here, I'll get you. I get you, buddy. Even I get timed out on redeeming my own alerts. That's bogus. It is kind of cool system, and so I have not been doing it consistently in here, but I'm working on making it more consistent. So I'll go back and I'll start actually using these type hints in the previous agents later. Probably once I get PostX done, we'll do some care and feeding of the 4 primary agents before we start expanding them some more. But hey, Frozen, happy Sunday, brother. All right, let's see here. All right, so our exploit step revisor. Typo inward. Revisor? Yeah. Okay, fine. We'll call it revise with the Z. I thought it was spelled with an S. Let's see here. So very similar to this. Let's go ahead and scaffold this stuff up real quick. Because we can basically just duplicate this. All of our helper functions here. Let's see. So once we get this, what we want to do is we want to go take from our exploit step, we want to get what do we want to get here? So what we're working in this object right here, the exploit step. We need a status on it. It's currently set to working. We can either say validated or failed. If it comes back as failed, we'll branch off and we'll do some more stuff in here where basically we try to revise that step and then send it back up to the step processor. So the way this will look is here. So we'll have another node down here, which is going to be our reviser. If it fails, then we will revise that step and we'll send it up to exploit planner. If it completes, then we'll increment what the current step is. We'll send it up to, to the step processor. Excuse me. Happy Sunday and Father's Day. Your dad must be really proud of you from above. I know he is, and I miss him a lot, dude. I was thinking about it because earlier in the stream I was talking about time seems to be flowing weirdly over the past year. It's been kind of crazy, and so it doesn't feel like it was just a month ago that it passed.
Incoming transmission from Frozen_Fushin. Happy Father's Day Sunday.
Thanks, brother. I appreciate it, man. I do appreciate it. It's actually a double bittersweet Father's Day because one, my dad passed away just earlier in May, and then two, my newborn son passed away in March. So it's been hard on the two fronts. So yeah. But at the same time, I don't just let myself spiral into sadness because I've got two other little boys and a wife that depend on me. And my wife's having a hard time with it too. So thankfully I told her, as we've been going through all these challenges in life, the wedge of life hasn't pushed us apart. It has actually wedged us on the sides and kind of pushed us together more. Dude, I'm trying. And in fact, sometimes I feel really bad because I know I'm having a bad day, and I'll be a little extra hard on the boys when they mess up. But at the same time, I just remind myself, it's like, hey, they're 3 and 6, and it's hard to remember that sometimes because they're both very big for their ages. They're tall. They're going to be tall boys, and they're both very smart. They're not dumb at all. So that's going to be good later on. In the beginning, though, when they're young and they don't quite have any inhibitions, they just go off and do whatever they want to. That's where it gets rough. So it's one of those things, doing the hard stuff now to have a better time later. Yeah, they are a lot of trouble. They're little goofballs is what they are. All right, let's go work on this reviser. All right, so after we get this, let's see. Let's go ahead and do an AI message here. So, do AI messages, and in fact, I think I want to type this real quick. Let me look at something real quick. So, AI message is a type AI message. Yeah, so I'm actually going to type this real quick. So we'll say this is going to be a list of AI message. And while I'm at it, I'm going to try and stick to doing this typing as these variable types as I come through. So we can get that, and then what we'll do, we'll append to this an AI message. And this AI message will be from exploit step revisor. It's going to say, what am I going to do here? We'll say checking status of step. And what we'll do is we'll make this a format string in here. And then what we want to do is do the current step. Actually, I want to do this. Let's say, yeah, we'll say exploit task, and then we'll have a placeholder for that. And then from here, we'll say I can't type. What's going on? And then from here, we'll say step, and we'll have a placeholder for that. So the exploit task index. There we go. And then we'll say the current step. Right there. Boop. There we go. This way, we'll get a little bit more tracking information to like what step and which exploit task we're actually tracking in here. It's okay. All parents are hard sometimes. My parents were hard on me when I was, when they had a bad day. They'll still love you at the end of the day. They are really sweet, and yes, they're very forgiving on that front. And so, I think one of the big saving graces that I've got is I explain to them why I'm getting onto them. I don't try to ever just like discipline or get on their case for nothing. I try to make it very clear, like, hey, this is why you're in trouble. The Cookie Monsters. I love the Cookie Monsters. Spirit Dance. I haven't seen that one. Let's see. So we'll say we're going to check the status of it. So what we're going to do is... Oops. I had a typo in here. There we go. Let me look at the prompts real quick. Can we reuse the validator prompt in? Let's see. That's our exploit suggestion prompt, post update prompt, enum template, task answer prompt template. I don't think we're gonna need. Yeah, we probably just have to go build this out ourselves, which is fine. New prompt in here. I mean, the prompts are basically the core of what's getting processed anyway, so we pretty much need just tons of prompts in here. I think one thing we might want to do is let me think about this real quick. So what we're looking at is an exploit step. We need to update the status of this. So what we can do is we can do a tool call and have it explain, is this valid and what was the status? And we just have it return the status value out of this. Yeah, I think so. Are they into computers and tech stuff yet? I mean, they're the typical computer addicts. I have been working, part of the reason why I mentioned earlier, I moved all of my computers into one space is to free up a separate room where I had like my workspace and my personal stuff kind of separated. They're now combined. So they're in still separate physical spaces. My work desk is over there. My personal stuff is over here. I did that to free up space to set up a desk for my son, so he can do his schoolwork and also that he can have a space to work on his own laptop that I've got him. It's running an educational version of Linux. I think it's called... not Elementary OS. I forget what it is. But anyway, it's a type of Linux that has like learning games and stuff. He's also very interested in Minecraft, and so he wants to be able to use console commands. So what do I do with that? I use that as incentive, like, hey, you got to learn how to read really well. And he is learning how to read. And he even knows how to do some algebra, because I have a math degree. I can work with him on it, and I can break it down and explain it to him very simply on what we're doing. I tell him, hey, man, we gotta figure out what X is. X is some mystery number, and we have to play detective and go unmask the mystery number. And he gets all excited about that. So that's how we approach it. So now the next step is, yeah, work with him on like learning how to do typing. The keyboard that he's got is a bit too big, so I've got a smaller keyboard for him. I'm working on slowly pushing their interest in that direction. But at the same time, I also want him to have a far more practical skills than I have. So I recently, a couple years ago, when he started racing, we would do ATV racing, working on engines and stuff. small engines, right? 2 strokes, 4 strokes, whatever. And so that's something also I want him to start working on. It's like, hey, yeah, we're going to go spend the day. We're going to go to your grandfather's house in the workshop, and we're going to go work on some engines. We're going to go see if we can get them running. So I got like some old beat up ATV engines. We're going to go work on repairing those too. Because it's still a very technical task. It's just a lot more hands-on than computers, really. Oh, they are playing at the same time, Bobby. I forgot to turn off the desktop audio feed. Oops. Teach some basic Python and then download Mindscript and you can control Minecraft with Python. That's kind of what I was thinking. I actually need to go... I know how to play my Minecraft from like the Nintendo Switch, but I never played it on the computer. Minecraft was a little bit after my time. Even though I had friends that were... when I was in college, they were like, oh yeah, you would totally like Minecraft. I'm like, would I really? I think I would just kind of like Legos. But actually, you can do some really fun stuff in Minecraft, so. I think we may want to do an output formatter.
Caution. A virus has been detected.
Hack_smarter virus detected in the network.
Type cookie in the chat. What's up, Tyler? Hey, man, I didn't think you were streaming tonight. I saw your big announcement, dude, about October 1st. That's going to be killer, man. I'm praying for you, dude. I hope it goes super awesome and you have just amazing success out of it.
Bullshit, I can't hear you. Sound off like you got a pair.
Man, don't you give me trust issues when you play that, and I know for a fact the microphone's working. That was supposed to be an alert to let me know that I was an idiot and had not unmuted myself. Hey, Classy, thanks for going online. Welcome in, Raiders, from the one, the only Hack Smarter stream. Counterpoint Phantom, what if you hack smarter and harder? By the way, I was watching you the other night, Tyler, after we raided out to somebody, and I said that. I was like, hack smarter and harder. I don't think anybody caught it, but it made me laugh. Let's see here. I think let's add a new output formatter. So for everybody who just came in from the very awesome Tyler Ramsby stream, my name's Blaise. I have been in IT for 15 years, and I've been doing IT security for the last, well, actually, I've been technically doing IT security for 10 years. I've been doing offensive security for 7 years, and just having a blast with it. So what we're doing on stream right now is I don't like CTFs nearly as much as Tyler does. However, I am very interested in agentic AI workflows. So what we're currently doing is we are building a tool, which I lovingly call Hack the Bot. And Hack the Bot is going to be an AI workflow and agent system to play CTFs. So we're currently working through building up the 4 primary agents. We have a recon, enumeration, and we're currently working on exploitation. And then eventually we'll have a post-exploitation agent that will link into Mythic C2 and then be able to handle all of our interactions. So the goal for each of these is going to be a little bit different. Right now, recon and enumeration are very identical to each other. Exploitation's job is just to get us a single command to execute code on the target, and then hand it off to the post-exploitation agent, where all the fun's going to happen. So exploit is going to be the single hardest one, because what we're doing is we're building in basically a speculative tasking. Everything that these guys works on is built off a task. So we build a list of tasks, we go through and we execute. But when it comes to exploitation, sometimes you got to guess. So we're building in what we're calling a speculative tasking loop over here, where it plans out the steps for an exploit and then goes through, and this will eventually loop through. We're still working on this loop right here. And it's going to execute all the steps and try and error correct for it. And eventually, if it hits a certain condition, which I haven't figured out yet, it'll say, okay, this exploit is not viable. We're going to bail out and we're going to try a different exploit method. And it should work through it. So far, it's working really awesome, though. And I'm having a lot of fun with it. So we're just building out this idea. And it's based off of this idea here called the Reflexion, where eventually we get like an initial response, we gather some data, we analyze or revise the output, and then we basically run through this loop here. So this section's done. We're building out this loop section right here. Love the t-shirt. Dude, this is an old work t-shirt. Dance like nobody's watching, equipped like everyone is. I love this shirt. It's actually also really comfy in my really obnoxiously hot office. All of my computers in here, I've got 1, 2, 3, 4, 5 computers within 10 feet of me right now. It's so hot in here. In fact, there's a 6th one that's going to be going behind me over there for my wife, codenamed Sock, to be able to play on. I have a Don't Drink in Roots t-shirt. I like that. It's so funny. Okay, let's see here. So we want to make a language model call that's going to validate, did this exploit step work correctly? So I think what we want to do is, these are our options right here for statuses. I'm trying to think how I want to do this, because I'm thinking about this error excuse me, this error correction loop. What we want it to do is run through, and when it hits this node here, actually I have a better drawing. We actually diagrammed this out. When it hits this analyzer node, it should render a verdict like, hey, did it work? Did it fail? What happened here? Can we do this? I don't want it to run through this infinitely though. There's got to be some kind of exit condition where it says, hey, by the way, this proves the exploit is not viable because we couldn't do this. I don't know what I want that exit condition to be. I don't want it to just say, hey, try this up to 5 times in here before it does that. Let me think. Because one of the downsides that can happen is we could get stuck in a loop. I've had that happen before while we were coding this. Let's see here. Let's go ahead and start with this though. Let's go ahead and get our output formatter here. And what we'll do is we'll do class, we'll do exploit. What do I call this? What did I call that? Exploit step status. And this is going to be based off a Pydantic model. Oh, wait, will this work? This will not work. No. Let me check something real fast. I'm trying to remember. Because typically you would use this with something called a structured output. No, okay, we could use this bind tools. Perfect. Yeah, I thought we could. I was drawing a blank there for a second. So what we'll do is we'll say this has one field. It's going to be a list of literals. And then what we do is we just provided a description. We say, hey, by the way, this is what this is. And in fact, I'm going to take this out because really it doesn't have to be new or working. It's just validated or failed. It's just going to be these 2 options in here. And what we'll do is we're going to hand check these values. We're going to say, hey, by the way, if it's validated, cool. Let's go to the next step. If it fails, we'll go through a secondary execution path that says, okay, let's do a revision. Is there something else we can do to potentially fix this step in here? So description is, what does this field represent? Let's see. The status of the exploit step. Validated if successful, failed if unsuccessful. Got one too many L's in there. Perfect. So now what we can do is, with this, let's come back here. That up. Here we go. Did I accidentally type something in here? Why is that throwing an error now? Oh, I know why. Our colon got deleted out of here, so it lost its typing. There we are. Like, why is this all of a sudden giving me an error? All right, cool. So what we're going to do is, for the revisor, let's make a note here of what we're actually doing first. So first thing we want to do here is check the step status. Call language model for a verdict. We'll have to go build a new prompt for this one, but it's okay. It'll be a kind of a small prompt. Let's see. How do I want to do this? We'll call this exploit step. Verdict? Is that what we called it? Or status? Status. Oh, the other ones called it a verdict. We'll call this status. And in fact, I'm going to change that in the output formatters. I did already. I already could call it exploit step status. Perfect. Let's see. Template. And this will be, copy this name. And actually, this makes sense because we have not, we haven't run through this yet. We haven't made this template just yet. That's okay, because what we're going to do is prompt going to be this guy. Happened. There we go. Copy this, and then what we'll do is we will run an invoke on it. It's a little bit broken at the moment because we need to go actually create this function here. So let's come over to our prompting Python. Let's go make this real quick. We will define this. It doesn't take any inputs. It just literally just returns us something. In fact, we could even do that here. We could actually say what we're returning. We're returning a chat prompt template. I'm trying to improve the typing notes in here. I've not been real good at actually putting the type hints into these functions. So kind of working on that a little bit. Let's go fix all of these real fast here. So same thing with this one. This one. All of these are basically returning the same type. But what it does is it helps the IDE come through and track, hey, are you storing the correct pieces of data in the correct spots? Right here. Put that in here. Same thing for this one. This one. That one. Perfect. And one more. So we got our return here. We got to go build these though. So what we'll do is we'll say our system template. And this is just basically a string in here. So let's see, for our system template is given the exploit task. Let's see, analyze the output. Actually, we could probably do that. So yeah, we'll say analyze the output and determine the status of if it was successful. Determine the... Actually, I don't want to... I take this back, because if I send it the entire task, what I was just thinking here is... So basically, we have an exploit step, actually. But it has this status field in here. If we tell it, go determine the status, there's a very good chance it's just going to go read the status field and do this. So instead, what we want to do is we want to send it just two pieces of information. What the actual step task that it was supposed to complete was, and the output here. tooling is really just a tracking list in here. It's not super important. So I do want to go redo this one. Even the... Actually, we can leave it as this. Exploit task. Analyze the output. It's output. Analyze the output and determine the status. Actually, yeah, we can just literally say that. I believe that would be good. Remove redundant parentheses. All right, fine. If we were doing this multi-line, we would want that. And then what we'll do is we'll say user template. Here. All right, I tell you what, I got to run to the bathroom real quick, guys. I will be right back. All right, I'm back. I do love the slide in. It cracks me up. Whoop. 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 I saw a funny thing. It was talking about really you families when they have kids, it's so the dad has somebody to play with, and that's pretty true. My kids are funny. They love it when I literally just pick them up and I hurl them across the bedroom onto my bed. It's a big, giant, soft bed, so lots of landing space. If I never stopped, they'd be perfectly content. Eventually, I'm like, guys, we gotta stop now. I have stuff I gotta go do. All right, let's see. So for our user template, this will be real simple. Because all we gotta do is just plug in 2 pieces of information. So what we'll say is we'll do our little faux XML here. And we'll say that's gonna be the task. And then we'll close that up real quick. more. Now we're going to have the output. Just like this. So what we're going to do is we're just going to take the task string and the output from that object and send it over to it. I cannot type tonight. What is going on with me? Oh, there we go. That's very much as simple as it gets. This is really, when you get down to the bare minimum, this is what a language model is processing, right? You have other ones where, like, hey, they're doing image processing or recognition and stuff like that. All they're doing is they're passing it to some other agent. Literally, large language models are designed to take in text and spit out text. That's it. All right, task output. All right, that should be good. What we need to do now is come over and import this, though. There we go. Let's see, so that's going to be our get prompt. I'm going to try and strongly type all of these various options in here. And this would be a, I think just a chat prompt. I think? Oh, we'll see. Because what we're going to do is we're going to run this invoke in here. And all we're going to do is we're going to pass it in a dictionary. So we'll say what the task is. So these are our two input values right here, task and output. Why is my caps lock up? Task and then output. Let's see, just like that. Yep. I don't know where it's pulling task from, but that's it. We're going to call this task string right here. And then output. Take that out. All right, so what does this type return? Or what does invoke return here? Let's see. Returns a prompt value. Okay, so this would be prompt value. Yeah, we gotta import that. There we go. Awesome sauce. Okay. Cool, so now that we've got this, all we need to do is come in from our current task and just extract those key pieces of information, and we'll be Gucci. Let's go back over here. So the task string would be a type string, and we're going to get this from the exploit. No, we want to get this from the step. Yep, there's our current step. So we actually didn't get the step out of here. So we'll do the exploit step. This will be type exploit step. And that is going to be from our exploit task. We're going to get the steps key, and then we're going to index it on the current step. Just like that. Oop, there we go. So our exploit step here, what we're going to get from this is, what does that field do? The step task. In fact, I'm going to make this all match here. Just like that. Excellent. So there's our step task, and then we also want to get the output here. So we're going to do the same thing. Output, this is going to be yeah, I was thinking if that needs to be a list, but you know what? It's not going to hurt anything if we do that. What's going on? Typing. There. So we'll make that an output type dictionary. And then same thing here. We'll basically just reuse this, and what we're going to do is we're going to put it to the output. Like that. Oop, there we go. So now our LLM call is perfectly set up. So what we'll do is we'll say the response is going to be Oh, we need to, I take this back. We need to set up the LLM. So we'll do LLM, let's see. Hey, Cyberstormy, thanks for coming online. Welcome in. It is a really good Sunday. Let's see. I don't necessarily, I guess we'll call it with tools because we're gonna be making a tool call, but not exactly. We're basically doing a fake tool call to get structured output back. That's what we're doing in here. So what we'll do is we'll do LLM with tools is going to be our LLM. We're gonna run find scenario, and then this is going to be our output format exploit step status, just like that. Need to import that from output formatters. And what's this going to return? I think this returns a runnable. Yeah, I think we would say this is going to be type runnable. I think that'll work. Okay. Now what we can do is we can invoke that. So we'll do LM with tools. We'll invoke that, and then we just pass in the exploit step status. Like that. And actually, this is going to return. So when we run this, it's actually going to return us the output from the runnable. So we want to save that as our response. Just like that. Oh. You've been hacked since the second grade. That's commitment, dude. It was hacking like as a hobby and indirectly. I did actually until about 1995 when I saw the movie Hackers and just had a mega crush on Angelina Jolie. Did I actually like start looking into it? Really, it was just by accident. It was just finding weird ways that things worked and manipulating them and tinkering with them. So really, the first system I remember, I guess, pulling off a hack on was I found a logic bug in a testing software that I found out if I answered enough if I did a certain key sequence and answered questions incorrectly enough times, it had an integer overrun, basically underflow, really, and I could get a perfect score on the test. And I really only found that because the test was so simple. I kept getting hundreds. I'm like, okay, what happens if I get a problem wrong? What happens if I just get the same problem wrong multiple times? Because you could go back and re-answer a problem. That's why I found it. But I'm doing good, man. Had a nice chill Father's Day. All right, so now from our response, what we want to get is we want to get the output from the tool call. Here. Did you do any war dialing? I did not. Unfortunately, about the time I kind of came up, war dialing was largely dead because the internet was becoming really more of a thing. And so I was really into freaking in the beginning. So like I built like my own red box and blue box back in the day. And I was so sad when I found out that like that had largely been mitigated by the phone companies by the time I came around. So now all the freaking is pretty much done over VoIP systems. Yeah, never had my own, Captain Crunch whistle. But yeah, that was kind of what got me started in electronics. Wish I had kept up with that more. That's actually something I'm looking forward to doing with my sons, is doing more electronics so I can learn it. Where do I learn how to hack the old-fashioned way? Really, the old-fashioned way is just, it's pretty much the same as the new way. It's just now it's a lot more hand-holdy because you can find tools that people have written. This was back then we didn't have GitHub, and you had to go talk to other people to find out information. Hey, Wingo, thanks for coming online, man. Welcome in. Yeah, the old-fashioned way pretty much was just like less automated and a lot more just figuring stuff out, which is the way I still encourage people to do things. I encourage them, hey, go through a system administrator course or book or something on the technology you're working on before you try to do a security course on it. Learning security methodology and where things can kind of mess up is actually fairly simple. The part everybody struggles with is they want to skip the foundational stuff and go directly to the awesome elite hacks. But what they don't realize is a lot of times the awesome elite hacks that I pull off are abusing the system administration stuff. a lot of times when I'm going through and I'm, especially like an Active Directory, and I'm messing around in there and I'm doing a pen test, I'm abusing probably 90% of the time built-in functionality. That's what I'm doing. Once I get a certain level of access, it's just it's pretty much just sysadmin mode. Malicious, basically bastard operator from hell type mode. That's where the real exploits are. Dude, think about like if you could just go back in time a little bit with current knowledge, how much damage you could do. So when Aleph 1 wrote Smashing the Stack for Fun and Profit and actually brought up the idea of like doing stack-based buffer overflows, that was like cutting edge. But people had been doing that for a long time, believe it or not. Let's see. So the response is something I'm always curious about, and I got to go back and check something here. Let's go. I think we can look in the over in Recon and look in Validator. Here we go. So see, this is doing the same thing. Oh, actually, I did this incorrectly. I forgot. We have a wrapper function. We don't ever call the language model directly, because we kept hitting an error where the API would fail with an overload error. And so we actually made a wrapper to do retries on those API calls. So what I need to do is go rework this. I'm glad I went and checked that, because we're not going to do that. I don't want to kill me, Smalls. Anyway, because what we're going to do is basically take all of this out. So we pass in the LLM and the prompt object. That's right. So our LLM is with tools right here. Oh, there we go. Just like this. And this is going to return just like a response from it. Let me go edit this real quick, actually. While I'm sitting here adding typing data. Yeah, actually does. Oh, we did already add the typing data to it. Nice. Excellent. Thanks, pass me. This is just going to be type output. And actually, let me go see, where did we import that output from? Output came from, yeah, runnable utils. So we want to import this from LangChain core runnable. I want to make sure I import the correct one. LangChain core runnable utils, yes, import that one. Excellent. So now what's going to happen is response, because of how we bound this this Pydantic model, we're going to have a key value called status that we can work off of. Awesome. Buffer overflows are the reason I love when people use C++. I know, right? I give Rust a lot of crap, but at the same time, I get the memory safety idea of Rust. Now, low-level learning has shown that you can make memory unsafe stuff in Rust, but it's really difficult. You got to go out of your way to do it. Actually, hang on a second. So I have this book that I have had for a very long time. Switch to Hacking the Art of Exploitation, 2nd edition. So I was actually considering, I was thinking about this. It wouldn't be for a while. Dude, do I still have the receipt? Hold on, no way. It's stuck to the glue in the binding. Hold on. How much did I pay for this book? I got this book from Barnes & Noble in 2010 for $54. How much is this book now? I'm curious. How much is this book now? It's $31 now. Man, I really overpaid. That was 2010 money. That was a while ago. I also got it at Barnes and Noble, so they always overcharge. But anyway, yeah, what I was thinking about doing was actually building out some Ludus ranges for the exercises in this book, because I still have the CD, right? I was considering doing that and then releasing it as like a series of videos exploring some of the topics in here and looking and say like, hey, this is where things sat in 2010 and here's where they are today, and kind of looking at it. Probably this is from John Erickson. Curious. Let's see, what books has he written? Sort by recent publication date. Let's see. Techniques de hacking de John Erickson, French edition. I mean, he has written some, I guess, more recent books, but I don't know how recent they are. I find it funny that this one's $3 for the Kindle edition. And it's funny that the first edition paperback is more than the Kindle edition here. That's funny. Book prices are ridiculous. But anyway, yeah, I was thinking about doing that because there's several lessons in here. And there's been a lot of like updates to it. So for example, looking at like programming, then exploitation, networking, shellcode, countermeasures. It's funny he called it cryptology instead of like cryptography. So I was thinking about that. If I do that, it probably won't be towards probably the end of the year because I have some other stuff in the pipeline I'm working on. But that was something I had been considering doing was, hey, let's look at what happened, how things worked back in the day and how they work now. Because even then, this one, when it was talking about exploitation, it was working on 32-bit and it was working without like data execution prevention and ASLR. And there's a lot of other stack protections and memory protections that are built in now that are a lot more difficult to bypass. So maybe I'll work on that. I'm still thinking about it. Well, it's like, what's up, dude? I have a question. I'm trying to get into AI stuff, but I'm having a hard time finding resources to learn. Got any recommendations? Well, let's start with your end goal. What do you want to learn about it? And then work backwards from there. Like, if you're just trying to understand how it's working, or some of this, then there's lots of different ones in there. One course that I actually like from Udemy is on LangChain from this guy, Eden Marco. This is kind of where I got started trying to dig into some of this real quick. And here, I'll drop a link to the course over in the chat. So if you're trying to get started with learning, that would be one area to do it. Now, if you want to learn about the security implications of it, there's an outfit called Dreadnought, and they are a cybersecurity company with some very good brains to them. And they actually have a... let's see if I can find it. This isn't what I wanted. Dreadnought Crucible. They've got an AI CTF called the Crucible in here. One sec. Let me see if I can log into it real quick. I don't remember how I signed into this. Let's see if this will work real fast. And this has a lot of different CTF style challenges in here. Oh yeah, this is the one. Here we go. So you can come over here to like, they have a series of challenges in here, like Granny, What the Flag. Actually, we did What the Flag on the stream quite a while ago. I'd have to go find out where we did it. Bear is like the recommended starting point for all of these. It's like introduction to different things. And it's really cool. So like we start with Bear 1 here, for example. It actually gives an explanation of, hey, this is how some of these different technologies work. So it's kind of cool because it's a learning and a CTF kind of combined into one. So here, I'll drop the link to that over here as well. The Crucible. Yeah, all sorts of really cool stuff in here. So it really, I would say start with what you want to learn and then start working backwards. Like, okay, well, if I want to do that, what's the step before that? What's the step before that? Start with like your end in mind and then work backwards. That's usually a good way to figure out where to start your learning steps in it. But really, the 5-minute overview of language models is they take in text, they do math, they spit out a probability of text that you want to see. That's what they do. So as opposed to something like a computer program, when you're executing it, it executes deterministically, right? You have branches, you've got code steps where it goes through and it's doing manipulations on data in RAM. It is truly deterministic in how it executes. If you provide same inputs, it should provide same outputs, right? Language model, not necessarily. You can provide the same input, but it's a probabilistic execution. So you're not going to necessarily get the same outputs whenever you do that. And just so you know, LangChain is useful for making like one-off calls and interacting with language models. LangGraph, like we're using here for this project, is for building things like this, these graphs, where we're saying, okay, cool, here's a node, it's making a language model call, and then we have other code that's making these branches. That's what these dotted lines are. And we're going through and we're saying, okay, if the language model response had certain characteristics, then go to this step. If it had other characteristics, come to this step, things like that. So LangGraph is focused around building out these kind of agentic workflows for your different tools. Hey, Aqua, yeah, man. Dude, that's what we're doing, having some fun with it over here. Let's see. We're currently working on adding, this is going to be a loop eventually. Right now, because there's nothing linked in the graph to the exploit step update node, it's going to the end node, basically saying end the graph call. And if in this case, it would actually return, I think, back up to, I think it would return back to the management AI agent. But eventually what's going to happen here, once we finish wiring all this up, this is going to be a loop that will execute in here. Does that workflow reset when, for example, you create a new chat on GPT? So this one is not plugged into a chat right now. Every one of these nodes has code execution that's happening, right? It's doing stuff, but they all take in exactly one argument. And you could actually put other stuff in here, but this is what's going to happen when you call it from LangGraph. It's going to take in what's called a state table. And in this case, we have a custom state table called the Stinger state. This guy right here. Really, the state table is just a typed dictionary over in Python. That's really what it is. And in fact, you see like Stinger state inherits down from typed dictionary. And we just have these different fields that we're manipulating in here. So every function gets a copy of the state table, and then we do some manipulation to it. And what we'll do is we'll just return the keys of this state table that we need to update. So if we have new AI messages, we'll emit, actually, let me find a better example here. Here we go. So like in this case, we've got a branch here that says, hey, if we see that we had a tool call, then what we're going to do is we're going to return these two keys, messages and tasks. If we don't have a tool call, we're going to say, hey, by the way, we're going to just emit a message back to the state table saying no tool call was found. So it doesn't really necessarily reset. It resets whenever I send it a new state table. And I've got a dirty hack happening here, where basically I bootstrap this process because I actually don't usually interact with the Stinger graph directly. What I do is the exploit graph. We run through the Stinger graph. It goes through and does some basic preliminary reconnaissance and enumeration and prepares everything for the exploit graph. When it hits that one, we actually are using Python pickle right now to take a copy of the state table and write it to disk. And then I can come through and execute this state table with a blank state, and it loads it from disk. So basically, I'm making a copy of that state table, sticking it on a disk, and then just loading it back up so I can run just this graph and not have to worry about rerunning all the previous steps. There's probably a better way to do that with some of the development tools the guys over at LangChain have put together, but this is the solution I came up with and it works really well. So eventually, this load pickle node is going to go away, and it would just start processing data from the state table that was passed directly from Stinger. So Stinger is the the supervisor agent, and then we have all the primary agents taking care of the main life cycle of a, let's say, penetration test in here. And then eventually there will be secondary agents down here, or what I call them specialty agents. So like there will be specialty recon agents like around Azure or AWS. Same thing with enumeration. Same thing for exploitation. There will be some specialty exploit paths in here. Want to learn how to build my own that would work with the DIY weather station I'm building out. Okay, I would say actually a good place for you to start their default sec is with N8N. N8N is a really cool tool. Let me see if I can find an example here. Templates. Here we go. And let's see if anybody has one for weather. Here we go. Send data. So here's an example of like what you could build with N8N, and it's a very low code to high code as much as you want to throw in it, but it works very almost similar to what we've got going on here, where you build nodes, they perform some kind of pipeline operation, and then send it to the next node in here. But with N8N, let's look at this one for example. You can actually see what it looks like. Here we go. Do you see if I can blow this up? Can I? Yeah, here we go. So, let me zoom in. So, for example, we have some kind of node here that kind of kicks things off. So in this case, it's triggered every morning, right? What does it do? It makes an API call, goes through and puts everything together, processes the weather data. And what's funny is, you notice how there's actually not a language model call happening in here. It's literally just you've automated a workflow with N8N. But one thing you can do is you can actually come through and have it, let's see. Here we go. AI agent for Olama with current weather conditions. So let's look at this one real quick. Here. So in this case, you can do stuff like this. You can actually, from a chat prompt, there's several little trigger nodes that happen in here. You could have it come to an AI agent node, and then you basically wire up the different areas. So, for example, you have an Olama chat model, you have a memory buffer happening in here, and then you've got some tools that are provided to it. Like, hey, we can make an API request to go get the weather. We can also check stuff in Wikipedia, and it works like this. So N8N is a really cool place to kind of get started. And there's just an absolute butt ton of videos on YouTube about it. So if you really want to start working in a simple way of like building workflows and interacting with things, I would start with this. And then you can graduate to something a little more complex like LangChain and LangGraph if you want to. Let's see here. Let's see, while the ads are running, let me take a look at what we left off. Okay, so we got the response. So what we'll do is we'll say, what we should be able to do is check the response dot. Oh no, we still need to go extract the tool call out of this. Oh, in this case, we did it with structure output. That's not what that's in the validator. Hold on. If we go up to output form, it's going to be different. Parsers. Here we go. Tool output is last message content. There we go. I think that's what we want. Okay, cool. Ads are finished up. So Stormy was asking, can you see the vulnerability with that state table? When you say see the vulnerability, you're talking about like there's a vulnerability with the code, because that would not surprise me. But in theory, what we're doing is, let me see if I can pull this out real quick, and we can kind of take a look at it. So, for example, what we've done is we've got a whole just ton of AI messages happening here, right? Actually, let's look at the load pickle, our output here. So we've got all these messages kind of keeping track of what happened, and we can actually run through this. So we start off the whole process right now with giving it a list of objectives that are happening, and then we keep track of what's happening to this. Now, there is a way we could actually go do like subtasks or like basically different state tables to pass to the different nodes. So let's say we wanted to blind a node to a particular value. We could go make a different state table, have that node operate on that state table, and as long as it returned the appropriate keys to update the state table, we'd be fine. I'm not worried about that for this. There are ways around like handling that data like that. So, for example, if you had an AI agent and let's say it was handling healthcare data, God forbid, and you didn't want certain pieces of that healthcare information going to an agent that's like just handling scheduling, right? Then what you would do is you would make a different state table with some similar overlapping keys to what needs to be handled, send the appropriate data to that agent, and then when it returns, those keys that overlap, they get committed to that first parent state table. I'm jittering data from sensors since I'm trying to determine whether locally out in the sticks where there's no signal or internet, but it's super helpful not to be completely lost. Oh yeah, man. One thing you can also do is if you've got, halfway decent computer, you can deploy N8N locally and be able to work with it there. You don't have to use it connected to the internet. And in fact, that's what I do. I use a self-hosted N8N at home for doing some different testing on various things I'm trying to automate about the content creation process. But no worries, Story. Yeah, something else, by the way, if you haven't ever seen this, there's another dirty hack, I'm all about those, that we've implemented in here, where notice how in this case, we're binding tools and they're called parsers. So what we're doing is we're sending output from tools to the language model and having it format it for us. So down here, we have some tool-specific output formatters. Really, the only one that has specific output is the Nmap output formatter. And then we have a standard output format. So I'm not so worried about these for the exploit steps, but for the top level task where it's like, hey, you need to scan and find out what's running on port 22 or what version of Apache is the server running, things like that. That's where these can come in handy because some tools don't provide like really friendly output. And we wanted to be able to update certain hosts that we were tracking with new information that can broadly affect them, namely Nmap. So we have part of the workflow in here is that, hey, if Nmap gets run, this information actually gets updated for the host, and then we kind of merge it together. All right, I need to do this part. In fact, I can take that out. That was the old way of doing it. Actually, I think this is pretty much, I can just copy this code section because I think that's exactly what I wanted. We'll just mess with it. So we do want to, actually this is incorrect because one thing I want to do is, we'll say AI messages here. I don't want to actually add a message. So the code looks kind of funny if you ever go look at the code up on GitHub. And it's because I'm learning things as we're building it. So the recon and exploitation agents were the first ones that we did. Unexpected argument. Oh, that's because I don't need this. There we go. And so as I'm learning new things, eventually, once the 4 primary agents get done, we'll do a quick repass and do some bumping up of the functionality, make it a little bit more robust. And then actually we'll start taking stuff like this away, where we provide this information. We'll start pairing this back. And we'll say, by the way, here's your target and here's your goal. And here's some basic information about it. So for example, for RootMe, what we might do is come in and say, let's see. Or let's see, does it have any information about this one? It just says a CTF for beginners, can you root me? So we might actually just back this one up like, hey, here's your target. Your job is to get a user shell and then get a root shell on this system. That's going to be, that's going to be a pain when we get to the post exploitation. Oh, it's going to be such a pain. Because now what's going to happen is we're going to have it to where exploit and postx can juggle back and forth between each other. Oh my. Okay. We'll figure it out. We'll figure it out when we get there. Post exploitation really is going to be the hardest one to happen. All right. Let's see. Let's see if we can finish this up a bit. So we want to append that response from the language model. Our output is going to be from our response. We're going to get the tool call. We'll get args. And then this is not what we want to do right here. I gotta remember what this is gonna look like. Actually, I can go look at, we'll see what this looks like when we actually do this. Let's go look at the state table. So I'm trying to remember the structure of this data as it comes back. Let's see. So here's an example. Look at all this. This is all the data we get back from an Nmap XML. Look at that absolute dummy McDonald's milkshake thick piece of data right there. And then what we do is we actually come back and we structure it so that way we can get nice, clean data of the important pieces. So stripping out all the XML and a bunch of the other extraneous data and just getting super clean information back from it. And then what we do is we update the host with that information. Let's see here. What I need to see is actually the state table. The actual state table, not just the messages. All right. So for example, we come over here. We should just have the one host, yeah. And if we come look at the output, let's find one that has a better output to it. Hostname, IP address, target server. It's funny that those are unknown, though. Those shouldn't be unknown. But anyway, this is kind of the information that we get back from this output right here. So this is a dictionary object here. I'm trying to remember exactly what this is going to return, what the shape of it is going to be. So we do a tool call, we do an exploit step status. That's going to return from our output formatters this guy right here. So what we actually should check is the status of this from our output. Let's see. So I think we can actually just extract this as the status here. Yeah. And we don't want to append this just yet. That was from a different piece of code. It doesn't quite apply here. So now what we could do is we could check the status, because the status should come back as validated or failed. If it comes back as failed, what we're going to do is we're going to then execute a secondary loop, basically saying, hey, we need to revise this step, or is there another way we can execute this step? Let's do that real quick. So we'll say status equals failed. What we'll do is we'll just put a little thing in here that says we want to... Actually, we'll start with the other one. We'll say that if it's validated. If the status is validated, then we're good. We don't have to do a lot of stuff on it. So we'll put a little note here that says we want to update the step and increment current step. That's what we want to do, and then otherwise, do else. There's an indent there. Oh, it doesn't like it because we just have the pseudocode in there. It's fine. What we want to do next is say else. What we need to do is actually what we could do. We don't even need to do that, because what we can do is if it's validated, we can just immediately jump to a return statement. So what we'll do is we'll return and we'll say update the state table. Otherwise, if this fails and it's not coming back as validated, let's see. I do actually want to say, eventually we'll want to have a little bit of an error correction here because we don't necessarily, what if it comes back with something other than validated or failed? I'll burn that bridge when I come to it. Let's see. So if it's validated, what we want to do is, before we do the updates, let's start with this. And then, unfortunately, I think we're almost out of time. So let's see if we can knock this out real quick. So if this becomes validated, what we want to do is we would update this information here. So what we'll do is we'll say the from the state table, say tasks. And what we'll do is we'll get, that's not like that. Index that on the current task. And then from the current task, we want to get the output. And then I think we want the, what's it, exploit task? Yeah, exploit task index. That's what we're doing. So we'll index this on the exploit task index. And then from there, we want to get from steps. This state table is getting so dense. From steps, and we want to index that on the, I think it's current step. Is that what we called it? Yep, current step. Let's do current step. And then from the current step, hey Deb, Teb, what's up? Welcome in. Thank you for coming online. All right. Then from the current step, we want to get the status. And we want to set it to validated. Okay, there we go. Yes, I think we'll be good here. So status, and then what we'll do is we'll set that equal to validated. Okay, so we set that to validated, and then we're going to do one more thing, and that is from the current step, copy all this. And you might be wondering, why am I doing it with all, when I have all those helper functions? I'm going to show you in 1 second why I'm doing it in this particular fashion. So from that current step, what we're also going to do, actually, I tell you what, we're going to back this up a bit. Back that thing up. And then from exploit index task, which gets us this exploit task, we have the current step right here. So what we're going to do is we're going to get that current step value. Let's see, current step. And what we're going to do is we're going to set that equal to whatever the current step that we extracted earlier. Let's see. Current step plus 1. Real simple. Just like so. So we were telling it we want to go to the next step in this. We probably should do a little bit of an error check in here to see like what's the size of the array. I got that extra tab in it. Because eventually we're going to run out of things like to go check for. But the reason why I did it this way is because now what I'm going to do is I'm going to return 2 keys here. So these are keys in the state table, right? We have messages, we have tasks. I'm going to return the those 2 things because that's what needs to get merged into the state table. So we'll say messages is going to be equal to AI messages. And now this might look a little funny because we initialize AI messages up here, just like so. And then we've only done appends to it. Why do you so like that? Oh, for some reason that got capitalized. But what happens is messages, you can just append to it. You don't have to actually replace it. But when we go update tasks in here, we actually need to return the entire thing. So now I'm going to return the entire task list to it. Even though we've only updated 1, I'm just going to return the entire thing. Oh, there we go. So this is what we're returning. So we take in basically a types dictionary and we return what keys in that type dictionary need to get updated. That's how the state table management works. Hey system, welcome back, dude. Pretty comfortable with JavaScript and Python, but lately I've been feeling kind of stuck. I don't have any good project ideas and I really want to work on something that helps me level up and improve my skills. Any suggestions or advice on how to get started? I mean, I always find that it's helpful to get an idea of something that is annoying and go fix it. So, for example, during my last penetration test, we had to do some particular tradecraft that everyone knows about but nobody uses because the tooling around the tradecraft is notoriously difficult to work with and very finicky. So, my buddy that I was working on this penetration test with, he and I are going to go through and rewrite the tooling for the tradecraft because we're tired of it absolutely just sucking. So that's how we were getting ideas on what to do with this. The way I came up with Hackbot here was I wanted to learn how AI agents work. I'm very familiar with penetration testing because I've been doing it a long time and security stuff. So I wanted to see, could I go ahead and basically build up a workflow for something like this and make it happen? So I would say you want to take something that you know and potentially try to implement it in a new way. And I recommend that to a lot of folks. So let's say, for example, you really like a tool, but you don't like the fact it's written in Node.js. Completely understandable and reasonable. So if you want to learn a new language, take one of your favorite tools and go rewrite it in a new language. That's one of my very favorite ways to do that. So find something that's annoying to you and fix it. Find something that's annoying to you and make a new thing to fix it. Or find something that you like that has an annoying aspect and rewrite it to get rid of the annoyance. Be warned though, if you take path 3, there's a chance that you're going to introduce new annoyances. Got an idea now? Baller. Awesome, dude. I am happy because you're happy. All right, let's see. So this is going to be the hard part here because what we're going to do is... Actually, I do want to put an else in here. So what we'll do is we'll do an elif real quick. So what we'll say for our little elif, we'll say if the status equals failed. Then what we're going to do here is we're going to have a error correction LLM call. And we'll have a return for this one as well. Let's do this. Boop. So we will have a return in there. And then last but not least, we'll have an else in here where like, this is going to be our bailout. Bailout because LLM call sucks. / fail. There we go. And we'll have a return for this one as well. So we'll say like, I'm just going to have a placeholder for it right now. I was really hoping I was going to get this one done. But the state table has become so chunky and so deep, it takes me a minute to think about which value we're actually accessing. And the reason for that is because the state table really is everything that we've got going on in here. So, and the way we're iterating over things is why we have these tasks right now. But it's fine. Let me think if there's anything else we might be able to knock out tonight. I don't think so, unfortunately. I kind of want to just go run it and see what happens. Is that we have not updated the exploit revisor to this. So what we can do is we can add that to the graph real quick. Let's see. I'm gonna put a little bit of flavor text in here. And then this one, actually, I'm going to move this up here. There we go. Yeah, so these will be just the nodes for executing the exploit steps. So what we'll do is, let's go wire this in real quick. So from the workflow, we're going to add an edge. And this edge is going to go from that node. Yeah, exploit step update. There we go. So do exploit step update. And this is going to go to exploit step revisor. And then now we need to actually create the node for that edge to land on. So we'll do exploit workflow, add our node in. And the node name is going to be exploit step visor. And then we tell it what the function name is of where that is. Bam, just like that. So now if I save this, and in fact, I probably need to save this file and this file and this file. Because as basically this server down here is looking for changes to the files and it will hot patch them in. So now you see, all of a sudden we have a new node down here, exploit step visor. Let me check something real quick. Is our server, are we still online? An hour. Did I catch it? Oh, I caught it with 5 seconds to spare. Awesome. And I'm going to go kill that box here in just a second because I'm going to do one more quick pass on it. So I'm going to make a new thread and we're going to let it run through this workflow real fast here. So we'll see if we get up. I'm fully expecting to get errors in the logic for the exploit step visor. Not such a big deal. I just want to see where it lands right now so I know where to pick up with for it later. Actually, it looks like it didn't actually throw any errors. So either I drastically screwed something up. Let's see what the language model call looked like. So given the exploit task, analyze the output, determine the status of the task. And so we have a tool applied here, right? The tool says, hey, here's our description that we applied for it because this is coming from the Pydantic model. You can either do a validate or a failed in here. We send the information. The task was to navigate to the file upload form. We have the output. The task was to navigate. Looking at the output, I could see the response, the HTML content, the form contains this. This confirms the navigation was completed. We got status validated. Oh, awesome. So for the revisor step, we come over here. Let me change this. There we go. So for our output, we output 2 messages. The exploit step visor is checking the status of exploit task 0, step 0. Perfect. We get the data back from it. We get the exploitation call, and then we update the tasks here. So let's go look at task number 5, because that's the one we're looking at. Actually, I probably should go update this note here, because we want to have the task, the exploit task, and then the step, because it basically makes a like a triple in there. But if we come look at 5, look at task 0, validated. Yes, awesome. So now it should start working on the next task once we finish wiring it in. Awesome. That is a great way to end the stream. Nice. Makes me happy. All right. Let's go see if we can find somebody to raid over to. So, by the way, for all the new folks, if you have not seen InfoSec streams, it is a really awesome. It is a very awesome especially very awesome website especially if you like cybersecurity streamers, folks like Tyler Ramsby or myself that are streaming on here. This is a great place to come see where they're active. Typically, though, late at night, we're the only ones on. I tried to get some more folks from like Europe and Australia that want to stream either very early or very late. Come on, get on here. I want to see 24/7 coverage on this site. Yeah, Stormy, come on in. If you guys want to chat during the week, so I stream on Saturdays and Sundays, doing this, basically working on some kind of a project. And then Tuesday nights, we'll do hacker news for the week. So we'll kind of do a recap of what happened over the past week and just kind of take a look at interesting news stories, see what's out there. And if you like that kind of stuff, that's really cool. If you want to talk some more, feel free to hop on Discord. I'm in there. I try to keep track of the messages during the workday even, and just see what's up. I'm from the UK and used to stream, but I'm still learning. Dude, I'm 41 and I'm still learning. I keep telling my son that. He's like, well, you're so much smarter than me. It's like, kid, I'm not smarter than you. I'm beating you by experience. I have 35 years of experience on you that I'm using to completely decimate you in everything that we do. He's like, how are you so good at video games? How are you so good at computers? How you everything? I'm like, kid, I've got 35 years of experience on you. I was doing all of this stuff before you were born. You'll get there. Be patient. Do exclamation point Discord in the chat and it will drop it in there. All right, let's go see who else we can find to raid out to tonight. If you have raid suggestions over on Twitch, feel free to shout them out because I totally will take them. Let's see, who else is in software and game dev? Let's see what we've got going on. Who's doing anything fun right now? Lots of game dev. Adam's online working on his indie program. Or his indie game. Escape room. Anybody else doing anything interesting right now? A couple guys doing stuff in here. A couple interesting ones. Let's go check and see who's over in science and tech, because I do love my science and tech. Fighting game controller that shocks you if you lose. Why are you in science and tech, though? No, I lost it. There was some interesting streamer there. It was, I guess, playing games over in science and tech with a controller that shocks you if you get it wrong. That was funny. Let's see. Surprised the earthquake monitor has literally 40 people kind of running on it. It's interesting. What are these folks doing? I don't even know any idea. The idea there. I think we'll probably go right over to Sid, because he's always doing really awesome electronics work. Let's see, who else is on right now? That's what. Actually, let me check one more thing. Let's see, DJ Tay's on. She's always good for late night working music. Oh, you know what? Nerduino's on. Maybe we'll go right over to him. He does awesome space stuff. Let's see. Actually, you know what? We'll go right over to Ragg because he's doing... what is he watching here? Sopranos? How's he even streaming that? I have no clue. All right. Let's go find out who we can upgrade over to. I tell you what, you know what? Moonwood's over there making an RPG. Let's go give him a raid and show him a little bit of love over software and game dev. All right, guys. Unfortunately, that's where I've got to wrap it up for tonight. I love you. Thanks for hanging out. I hope everybody has had a fantastic Sunday and Father's Day. And we'll pick this up Tuesday night with Hacker News. We'll see what's going on in the nice, big, bright world of cybersecurity. And that's it, guys. Hey, tomorrow's Monday. Cases of the Monday are verboten. I want you to have a case of the Crushing It and absolutely just go wreck this week and beat it like it owes you money. I want you to go out there and just kick all levels of Butte. And really, that's all I got for you. Oh, wait, no, I take it back. I got one thing that I forgot, and that is, I love you. Peace.